All right, so to start off, we're going to go through what I go through to prepare the assets for this project. This part isn't particularly necessary if you're not interested in that method because I'm going to provide all the finalized cards. Um, so uh, out of the Kenny asset pack, the 1-bit, which I'll be linking below, for those that want to follow this from creating the assets from scratch or modifying the assets rather, we're going to grab the monochrome packed PNG. There's several PNGs. This is under the tile sets folder in that pack, I believe. Um, it will be located if you download my asset pack from GitHub. It'll be located directly under the assets folder and directly in the front. So we're just going to move it into this program Pyxel Edit, which is not open source. It's a paid product. I'll provide a link below if anybody's interested in it, but you can do exactly what I'm doing just by individually cutting out all of the cards into their own image, which isn't as hard as it sounds, but it's definitely more tedious than using this software for it. So we're going to pick tiled image. Um, as you can see, the asset pack itself is very big. We're going to only use selected tiles. The tile width and tile height will be 16. And because we're using the packed, there is no offset. So everything is just crammed together. And you can see that it has a little grid already placed to confirm that everything is lined up nicely. And because we're only using selected tiles, we have to manually click through all of these. So I'm going to do that really quickly and pause recording just for ease of editing. All right, so here we go. You can see that all the cards are highlighted black to indicate that they're selected. It's very important that you click to import tiles or you're going to have to do that process in Pyxel Edit manually, and I'm not planning on covering that in this tutorial. There's an excellent tutorial series on learning how to use this program, just the basics, and I'll post a link to that below as well. So we can tell everything's going right when we see the tiles here to the right. Um, we can adjust the width of this to make it more readable. So there are 14 cards per row for 4 rows. So now we'll see that this basically matches the layout there. So now that we've done that, the next thing we're going to do is we're going to grab this, lower the alpha to 0, and grab the paint bucket tool because we want to make the edges transparent of all the cards. So as I've clicked there, everything's transparent. There's still the white pixels around the cards, but it's really hard to see. So once that part's done, it's just as simple as going export, and then we want to export the tile set. We want all of the tiles as separate files, and the pixel per scale has to be 1. PNG is fine. And once you've put it where you want it, you hit save. The tedious part, I'm not going to bother hitting save here because I already have it. The tedious part is that you will have to manually name the cards, which is actually important for this project. So here we can see I have all of them imported and naming using my naming convention. The one that looks just like a large spade I've called card, and the other three I've called the other 3 card backs I've called card back 1, card back 2, and card back 3. Everything else is labeled by a camel case of the suit followed by the value, with ace, queen, king, and jack being named. And this naming convention is important. Like I said, I've already prepared these assets and they're going to be linked below. So if you don't want to manually do this for the experience, then that's fine. I should mention that it's quite possible without the software I used, Pixel Edit, to do this. It's just slightly more tedious. You just have to copy and paste 16 by 16 versions of these cards into a 16 by 16 PNG file. Basically just make them separate. It's fairly easy to do in Sprite if you're using that, which is objectively free. It does have a cost as a paid software, but I believe you can still, because it's open source, just build your own version of it, although I do recommend supporting the creator of that software. And you could also go through a similar process in literally any pixel-based editing program, including GIMP, I guess, would be the most notable free version of that. And you could probably do it in Paint as well if you really wanted. So now we're going to move on to preparing the project itself. All right, so we're going to start by creating a new project. And we're going to browse to wherever we want to put it. I'm setting this up for GitHub, so we will put it there. And I have no need to create a folder because everything's good. So we're going to use OpenGL GLES 3.0 for this project, although I think probably everything I'm doing in it will work in ES 2.0 if somebody is planning on making this for a wide distribution mobile release. But I don't know if that'll be the scope of this video series. We'll see how it goes. So hit create and edit. And the first thing I like doing, well, we can either go into the project settings or just start with a base scene. So we're going to create a main scene right off the bat. It's just going to be a standard 2D node scene. For anybody that didn't track that, oops, if you, I clicked on the 2DC button there. And just renamed it main by clicking on it and typing main. I'm going to assume that there's at least a little bit of familiarity with the UI and Godot for this series, because I don't see it being necessarily the first series people jump to, but if there are any questions, just ask in the comments. I'll try not to to breeze past anything really, but at the same time, yeah. Anyway, so I'm going to drag this icon right onto the scene. The reason why I'm doing this is because the import settings on these things, if we zoom into this texture here, you can see that the PNG file is really blurry along the edge. So we're going to change the preset to 2D pixel and re-import, and you'll see it crisps right up. And then we're going to put set default for texture, and that way any other assets we bring into the file that are PNG or other texture files, they will automatically have these settings. And that should do for this project. So we can delete this icon now and continue on to project settings. So to start out with, we will go simply to the display. For this project, just looking at my reference here, the display will be 600 by 400, which is relatively small, but we're doing kind of a blocky pixel art style. So, but at the same time, because the window is going to be relatively small, we want it to, most people want it to be displayed a little larger, including myself. So we're going to increase the size a bit in the test value, which will make it expand automatically on load. And then we're going to change the mode to 2D, which just helps with rendering the sprites if they get expanded. And we'll change the aspect to keep, so that if the window gets resized, it keeps the aspect ratio of the project. The next thing we are going to do is we're going to select the main scene. We can do this later, but we might as well do it now. So on run here, we're going to select the scene we just made, which I did not save. So yeah, make sure you save your scene. I'm going to save the main scene right here in the root directory. It's not necessarily best practice, but I kind of like having the entry point to my program being easily accessible right in the root node. So again, project settings, run, and we're going to find that scene, and that'll be the first scene that loads whenever we try testing using the play arrow. Now we're going to go to the rendering settings under quality, and we're going to go to, where are you? The 2D setting here and use pixel snap. And I think that's all we have to do there. Actually, so in the asset pack I'm providing, there is, in fact, I'm just going to import these right now. If you have my asset pack, it'll have a folder called graphics, and you can just drag it right in there. That pack contains all the cards that we made in its own folder, and it also has the font that we're going to be using, and this, and I actually haven't added the asset I'm talking about, so just give me a half sec. Yeah, so it'll have another thing called Godot black.png, which will be right in the graphics folder. I just used a different pixel editing software, Sprite, to make this, but I just think it's a cute little bit of flair to add. So if we go to the boot splash, we can actually change the image to Godot black.png. And you can make your own custom splash screens for when the program starts. If you're not interested in having a splash screen, you can actually make it so that it's just a black square if you prefer. I notice I have a blue in the background instead of black. I'm going to probably change that by the time this video is released. So that is about it for just setting up the project for our initial playtime. The only important thing to remember is that when you add resources to this, whether you're making it manually or just putting in the resource I have, that underneath the root is the graphics folder, which will have a card folder containing all of the cards. Um, I'm storing the fonts and random graphic stuff just right here, but eventually I'll add other folders to this as the project expands for organizational purposes. So let's talk about the organization of this project. So here's a quick little diagram I did. I'll pretty it up as we go, but ultimately the scene's going to be comprised of the main node, which will have a script which controls the state machine of the game itself. Below that will be the card controller, which controls, it itself is just going to be an empty node, but it's just going to be used to contain these, which I'll get to in a second. And the UI node, which is going to contain everything I need for displaying messages and that sort of thing, menus. The card controller is going to consist of three main components. There's going to be the deck, which is going to keep track of all 52 cards and make sure that it's distributed to the correct hand as it goes. The card itself, and then the hand, which is going to have basically subclasses. Basically, the hand will have its own script that has stuff that's common to hands, so an array to keep track of what cards it has, etc. The table will take that, and it will also have basically contain, it'll be where all of the table cards are instanced for the flop, turn, and river, and the card that's played during the war portion. The player hand will contain the whole cards and how they are displayed, and the enemy hand will do the same thing for the enemy. The unique difference between it is that the table will display the cards basically in a vertical line from left to right across the table. The player hand will actually follow a curve so that the cards are arced as if they're held in a hand, and they will also be a little bit bigger because for UI, just for game feel purposes, it'll feel like you're at the table and you're looking at the cards, and the enemy cards will look smaller and will be in front of the enemy, the picture that we have that represents the enemy, and it'll be a lot smaller. So these will be separate to handle those details, and in addition, the player hand will be used to keep track of of player actions, like what happens when a player clicks on a card during each round of the game or each part of the game. And the enemy hand will deal with the AI aspects for the enemy and what it does during its turn. So we're going to start by creating the card scene, which is going to be its own individual special scene. So we'll create a new scene and hit other node, and we're going to make a area 2D node as the base scene. We're going to rename it to card, card, not cared. I'm holding my keyboard at an awkward angle here. And we're going to add to a child, as a child for that, we're going to add a collision shape 2D for when people are clicking on cards. And we're also going to add a sprite. Oops, that's not what I wanted. Let's delete that. Sprite, there we go. And we're going to add a tween to help with movement effects with the cards. There'll probably be a couple other nodes we add, specifically a timer node, but we'll get into that later. So we'll leave it how it is, and we'll add a script to it. We're going to create a folder called scripts, and we will save this in it. For this project, I'm just keeping all for the organization. I'm using a simple, sometimes frowned upon, sometimes some people prefer it. I'm putting all the scenes in one folder and all the cards in another, with the exception of the main scene. So it's scripts, card.gd, and yeah, everything else is fine. So the first thing we have to worry about for the card is setting the variables that are essential for this. So we'll start with var card name, which will contain just the name of the card spelled out. That's going to be used primarily for testing purposes. It doesn't actually come into play in any of the game coding, so it can be removed later on in the project if you so desire. Card value and card suit. And we're also going to do an export of type texture, and it's going to be called card sprite. This is where we're going to hold the default sprite for the card, but the sprites are going to be generated through code. And I think, yeah, so we should add a variable because at some point we're going to be setting the card scale depending on which hand has this. So we're going to create our own variable called card scale rather than using the default scale value to modify it. And it's going to use a set get. And what set get does, for people who don't know, is it allows you to, anytime somebody tries to modify a variable, through another function or whatever, it will automatically call this function in order to do it. So we're going to call the function change card scale, and then of course we have to create it. Wrong. Change card scale. We're going to underscore that at the beginning because scale is an actual thing that can be modified. It's like a default value for changing the scale of the sprite directly, which we're not going to be using. At least not there. We're using it here. So scale will be equal to scale. And that's all that function will do. And we're going to add another function for changing the sprite. It will be used primarily for the bad guy script so that we can change all of their sprites to card backs instead of the actual card values. And that should do that. Anything else? Yeah, we'll make one for card width too. Again, because depending on where the cards are, they'll be the scale will be changing. I'm going to have to access the card width for various functions for making sure that all the cards are aligned, depending on whether they're in an arc or in a straight line. So the card width will equal the sprite texture get width times sprite scale dot x, and this will return card width. Perfect. And that's pretty much everything that the card's going to do right now. Eventually we'll add some functions to it so that it jiggles and stuff and pops out when you're hovering above it with a mouse. But for now, this is perfect. And I don't think we have anything to add to the ready function. All right, so we're going to save this. We're going to create a new folder called scenes. And we'll save the card scene here. Oops. All right, so that's the card. All right, so the next step is to create the card controller. We're just going to go into main, add a child name, main rather. We'll call it card, oh sorry, it's going to be a type node. And it's going to be called card controller. And it's just a blank node, it's just for organizational purposes more than anything else. And we'll add a child to that, which will also be a node. And we will call this one deck. And we will right click on that and we will save the branch as its own scene. Under scenes, save. We'll click on this little movie clapper thing and we will immediately add a script to it. So it's going to be under scripts and we will create that script. So for the deck, which this is literally all it consists of, is a node. So it's just for organizing the data of the deck itself. Initially, there's a lot of typing just to put in the variables. So I'm going to just copy and paste that out of my reference code. It's very important that the variables are named the same. Again, we can choose to not use card names if we wanted to save us some time. But ultimately, I find it handy for testing. So basically, there are 52 members of each array representing the 52 cards and their values. The names are here, the values from 1 to 13, 1 being ace and 13 being king. And then, of course, 13 instances of spade, heart, club, diamonds as strings variables. And finally, the most important variable is the deck, which is the array that once we build the deck will contain all 52 cards. So for the ready function, we're going to want to randomize. Randomize basically makes it so that when we start doing random stuff like shuffling, it generates a new seed every time. Otherwise, Godot will just use the same seed. So even though it'll be a random number, it'll be the exact same random sequence every time, which is handy for testing, but we do not require it. And then we're going to create a function called makeDeck, which will create the deck itself. And it will be run on ready. So let's make that now. So function makeDeck. And we're going to reference the card scene that we just created, which you could copy and paste it as well. which might have been faster actually. So to copy and paste it, you could get the path just by going into here and copying the path and then pasting it in. We're going to create a variable called card, which will hold each instance of the card as we're making them. And for I in card names, we can pick any of these card names, card values, or card suits because they have the exact same number. And it's important to get the size. So card will equal a instance of the card scene variable that we just declared. And then we're going to take the variables that we set in here, so the card name, value, suit, and etc., and we're going to assign it appropriately. So card name will equal card names I. So for anybody that's unfamiliar for for loops and how it works, this I number will iterate until it reaches the size or the amount of elements inside this array card names. So sequentially, it's basically going to create each one of these cards by using this variable I. So the first card will create a card and instance it, and it will give it, it'll change its card name value to cardnames.I, which is the ace of spades for the first iteration, and then when it does the value, card value.I, it'll be 1 and then spade. No, that's incorrect. There. Now after we do that, we're going to want to make sure we actually add it to the deck using the append command, which appends whatever you put in these brackets to that array. So it adds a new element to that array, which is going to be this card thing. So it's going to be a reference to this instance of card. And then after I'm done all of that, we're going to take the deck array and we're going to use the shuffle command to it, which is going to randomize the order. And because we use randomize, we're going to have a different outcome from that each time. The next function we're going to create is for giving cards to players to call the function. So give cards, and it's going to take a number, and it's going to store its return in an array, which is going to start an initialize blank. And then we're going to iterate again with a for loop. For every card that's been requested, it's going to first append to the card return array the value of whichever card we're on. So if we've driven 5, we'll take the first 5 cards from the hand array and bring it into card return. And just for testing purposes, we'll add a little print statement in here. And then we're going to iterate again, but this time through the card return itself. And for each card that's in there, we're going to go to the deck array and we're going to remove the first element. And that's basically going to make it so that the first thing it's going to do is going to grab the cards it needs, and then it's going to destroy them from the original deck. And that's it. So yeah, that should be good. And we'll return the card return. And we should be golden. So if I hit play now, or sorry, I have to do one more thing. I have to go to main, and we're going to create a script on this. And the first thing we're going to do is we're going to reference our deck. So on ready var deck equals deck. And then we'll make, just for now, this isn't going to be, we're going to create our own deck variable. We'll call it cards, I guess. Sorry, distracted by my own syntax here. So we're going to go deck dot get card. What do I call it? Deck dot give cards. And we'll ask for 2, and we'll actually just say there, so that'll make that array, and then we'll get it to we'll just get it to print the cards, which isn't going to display necessarily what you think, but we'll do it anyway for testing purposes. So let's just give this a run. So from the first print statements that we put inside the hand thing, it generated these 2 cards, the Jack of Hearts and the Queen of Spades, and those were printed using, using this print statement here. So every time it appended a card, it printed the card return card name. So those were the 2 cards that were dealt. These here are actually like pointers to the actual objects, the scenes of the cards. We're not going to be using those too much in this example, but that just shows that those 2 cards were passed, even though the value isn't there. I could have made a fancier way to print out those names, but I just kept it simple. But we know everything's working, so that's all that's important right now. So I'm going to stop here, I guess, for now, since we have output. So we'll call that success, and we're going to work on making the hand scene next, and then eventually expand that into the player and enemy hand. I'm not sure if we'll get all that done in the first video, and then we'll start printing up our scene a bit too. I'm not quite sure what the order of everything is. I'm trying to do this with kind of a bare minimum amount of planning, but a bit of a script so that I don't waste anybody's time. But we're going to stop this video here, and please feel free to leave comments or questions below. We'll post a link to the GitHub for the project, as well as a GitHub direct link for the resource files. Have a good day.